Good evening, everyone. My name is Rainer Aus, and I have been invited here to share some thoughts into the topic of cloud native networking. As a bit of a spoiler alert, there has been advertising regarding the networking in WISE. But today's presentation will more focus on philosophical aspects of cloud native and a bit of ground native networking, and how to do things wisely from day zero to spend the least amount of resources on redoing and wasting. As with everything novel, the most important aspect is the element of surprise, especially being ready for the surprises, as it comes. Unfortunately, it's the burden that comes with all the innovations. And secondary important aspect is knowing your application and being able to support it on the network level, because often problems that do not appear to the specialists of the software stack. For example, Kubernetes. So network engineering is the function that has to be aware and aligned with Kubernetes and platform engineers. Even though networking is considered as a lower layer of the infrastructure, its voice still has to be heard. And if you see anything not so smart on the table from the engineering team, it's fair to presume that nobody just knows any better, because the example of Kubernetes is really complex, and the application engineer's primary goal is to be proficient on the application and not so much on the networking. So the voice of a network engineer has to be heard. Rest of it is pretty basic. In addition to believing the specs, things have to be tested. So lab environment is still your best friend, as on ground, thus also in the cloud. And extremely crucial aspect is vendor relations, as basically your business depends on the cloud environment. You really have to have a very short communication chain to support, because if something fails, then you need to be quite instant on the communication to the party who really cares about the health of your infrastructure. And as mentioned previously, the aspect of novelty still applies, that often you are unable to predict the failure mode. A bit regarding the preparatory aspects. as in any environment, also in cloud environment, it's your job to know your stack. And as always, there are restraints. Based on my experience in the cloud environments, the restraints can be a bit not so straightforward. So it's definitely a good point to read up on them and focus on the restraints. Default values of certain settings, max values, the fact if these are soft or hard maximums, and what is the procedure of upgrading those. And of course, monitoring for those parameters to know where you are in the situation awareness aspect. And as with everything, you have to test or benchmark theory versus practice. And if you have any doubts, then the best approach is to find out yourself and just clarify any unclarities in lab environment. Wrong decisions will punish you. It's good to know in advance the severities of the punishment. One very typical gotcha is the subnet sizing failures. In cloud environments, you basically hard code this value at the moment you create your VPC. Environmental object, and you, as you have already instantiated services or machines there, you cannot change it. So in case you run out of IP addresses, then you're pretty much screwed with the only alternative of redoing all the precious work you have done. And of course, this issue comes at the worst possible moment, etc. So this is why that fact has to be acknowledged as a starting point. That you have to plan these things in advance, and misplanning can be rather painful. Second aspect is address selections, especially if you aren't sure with certain degree of over provisioning, because you can always optimize later, but again, when you run out of resources during the run, then business-wise it can be very painful. Third important takeaway is that whenever you are thinking about any solution, then think of the future and different aspects of scaling, whether you want to set up these services in geographically dispersed way, what are the volumes you're going to be handling, and also how many people you have. And actually the organizational aspect is I would say the most crucial in terms of making these decisions, because in reality the experience is that most technical solutions, regardless of their price tag, are usually cheaper than trying to compensate technical inefficiencies with adding people. because this will grow exponentially in complexity, and it's much more difficult to handle than technical choices. As with all the engineering, then simple solutions rule. It would be in your interest to chase for determinism in solutions, especially if you are planning failovers or high availability solutions. Then you definitely do not want to just implement best practice design without understanding how it works. Again, like with application, you have to really get to know this determinism factor in practice, how it works, and the most interesting part is in which cases it does not function as expected. Consistency is always good practice as you are dealing with fellow people who use the same system in different roles. Then always beware to put the UX consideration into your works, because if you deliver a VPC full of instances or services which only have the instance IDs without no human readable naming, or network appliances with hundreds or more interfaces without any descriptions, then it will really not help your business in terms of agility. Regarding different flavors of code, then the logic is still the same, that think of also other people and think of ways how to increase their productivity. I witnessed situations where as a code approach has been taken as the highest priority, and ramming through a technical solution by trying to deliver it as code has taken months, while really optimized solution could have been that one engineer creates the topological design and it's actually turned into repeatable code by a fellow. So in such a cooperative combination, the delay would have been likely days only. So such human-friendly combinatorics is very important for any cloud-native development team member to witness and also bring out. And as always, on the topic of documentation, documentation is your friend, and approach it as soon as possible, preferably in the very beginning of the work, because as the people are in general lazy, then such yes, I will do it later documentation usually doesn't work. Has more errors when you I would say the successful approach is that you create the design documentation during the system creation and just rename it to as-built documentation when the solution has been completed, and everybody, including yourself, are much happier. In terms of the infrastructure, beware of blast radius of different likely failures, and place your workloads accordingly. In case of cloud vendor software bug, then you are pretty much helpless unless you use alternative cloud vendor as your failover scenario. The rest of the issues are of higher impact, likely, but still you cannot really predict them very well. So the more careful you are, the better the result. One aspect I would like to bring out here is designing your failover scenarios symmetrical so that they're even. All sorts of asymmetrical backups may seem a good idea on paper and by people who discuss them briefly in meetings without any intrinsic knowledge how the technology works. In reality, all asymmetric backups are a bad idea because you don't know where the failure appears and you don't know your volumetrics at the time. So most likely the backup is too narrow and it will just not work. So if you design it, then design it evenly so you could use either part of the solution as the working solution. Regarding disaster recovery exercises, I have crossed it through as this concept in itself is a kind of flawed and it gives a false sense of security when you conduct them and make conclusions based on the results. The failover has to be designed into the system and has to be practiced often. For example, if you have several backends, keep them all in work. If you want to upgrade one, then fail everything over to the side B for the time, because this gives you clarity whether your system works as expected, and also gives you these good cloud native practices that you don't have any untested code or untested backends which activate when you press the silver button. Well, the experience with such emergency silver buttons is that they are generally outdated, even on the cloud-based world, when you implement them. And again, it's not a good practice. It's not very agile. And regarding the disaster recovery plan, it's very important to understand that in a cloud environment, you're in a shared environment. And when you experience disaster, so do your co-tenants. And they also likely have disaster recovery plans. So when your plan is that I'm going to run my provisioning code when my active workload fails, for example, to set my infrastructure up in a alternative region, you can predict that everyone else does the same thing. So basically the API load is not zero, and also you have to understand that the delay for the provisioning code is not zero. So basically, only way to survive such a failure is to have your infrastructure prepared in advance. It's costly, but creating it from scratch will take likely days. Anyway, it will take too long for your business to survive this. So, though this reason, it's crucial to be prepared. A very important topic is monitoring, and the cloud brings novel traits here as well. It's not enough just to monitor the technical parameters, but you also have to monitor for those bottlenecks and limits we discussed earlier regarding the cloud vendor parameter list, which which prerequisites you to know those. Also important to know the API validity, because APIs get obsoleted sometimes, and it's very bad to discover this during some failover event when you really need this API call to work. Same applies to provisioning code. It has happened that release upgrades of certain provisioning tools have proven to be backwards incompatible, which means that when you try to run this through your CI pipeline for disaster recovery, they just throw you a bunch of errors. Totally different aspect is cost. You really have to monitor this in order to prevent any bad surprises in the end of billing period. Whatever the solution is that you use, it will be a good investment, because there are situations where cloud environment puts you up with interesting cost fluctuations, which you just have to catch and process with your account manager as soon as possible to get clarity. But this is very important aspect. And the last aspect I would stop on is the remote workers' connectivity. This is something that basically the whole organization depends on in terms of productivity, and there are surprisingly little amount of solutions to provide this out of the box. So basically end user VPN connectivity. This is important in order to debunk the myth that, well, I think the meme that network is not working is available in any technical organization. But it's very valuable to understand the behavior of the internet internationally when you have offices, for example, in Brazil or US, and in case there is a incident where a lot of Brazilian colleagues are disconnected or face packet loss, then you can report them preferably automatically that, hey, the Brazil just faced some submarine cable outage, and this is why connectivity towards AWS will be impaired for the following hours. Okay, now we'll get to the specific lessons. I guess the novelty of failure modes we already discussed, but this is definitely the key aspect when talking about cloud solutions, which largely work as black boxes for us, that basically anything can happen. And this is why the communication line to your admin contact at the cloud provider is crucial. This can be in many forms. In reality, yeah, we can perhaps discuss these individual options after the presentation. But basically these failures give a pretty good overview how the black box is designed. For example, where some crypto hardware misbehaving impacts all IPsec tunnels running in AZ or over the AZs. Lesson 2 is related to the human aspect, that when you create objects or configuration, then don't forget your colleagues who perhaps are digging on the problem or development project on network appliance level and need to work on it also on the instance level, but without specific hard coding. It's really impossible to find out what instance is, for example, Juniper firewall under which account. Okay, I've been speaking rather monotonously. A bit of a wake-up question. Which ports do you think does SSL VPN need to function?
When you say SSL VPN, who is the vendor of that?
Let's say generic implementation.
Bunch of ephemeral at least.
Okay, but if we try to stick to the definition of SSL VPN.
What is the definition of SSL VPN?
Well, probably some partition running over the HTTPS protocol.
Mm-hmm.
So for free.
Okay.
I think OpenVPN would, in TCP mode, will also constitute as SSL VPN.
Yes.
So that would be 1194.
Mm-hmm. Okay. Okay, but which protocol?
It's the OpenVPN's own protocol.
On top of TLS.
Yes, on top of TLS.
Okay, so TCP or UDP?
TCP. You can configure it with TCP.
Mm-hmm. Okay. Yes, very. Why I was asking is that very common issue is to get stuck on the appliance level and miss the importance of the security group VPN rules, not network access lists rules. And when it's ordered from colleagues or different department or somebody else, so basically you order only the ports that they assume you need, which gives you TCP 443. And now for a poor network engineer who is trying to debug this on the appliance level, will learn this platform quite well, because he or she is trying to understand why the throughput is so low. And the fact is that there is just the UDP port allocation missing one layer below on the instance level. But getting to such problems can be very difficult if the linking is not done correctly or properly. Tooling has to be addressed in advance. The implementation will depend on the application where you need it, but you will need it, or your colleagues will need it. So it's good to think of a way in advance, because it's not a pleasant situation where you need to debug a working Kubernetes cluster without any way to really see inside or try to use any traditional tools with the Kubernetes admin likely as helpless to advise on the networking aspects of Kubernetes. Besides that, it's not working. A very important technical aspect is IP addressing. And generally, while using cloud environments, you are stuck with using the private address spaces from RFC 1918. And I guess the situation description is pretty familiar for the most of you. Yeah, from either side. And it's a big problem, and there are some solutions to it, which we'll get to on the next slide. But the main issue with security I would like to point out here is that whatever you do, don't accept any overlapping prefixes from partners. Either you have pairings with some application provider or whatever. Not sounds as a bad idea from the past, but it's not as bad as letting rogue IPs overlapping with your ranges to your system. Because as a Murphy law, the range they will appear from will likely overlap with your super special secure management range, which has some very intricate accesses to your systems in the access lists. Now a bit of eye training has different concerns about not using IP addresses from certain ranges. I can confirm that the do not use is not optimal advice here, because if you don't use them, you really don't have anything to use. So you pretty much have two large scale alternatives. One of them is using the private ranges and securing and sanitizing all the edges with NAT, either with AWS means or some extra security appliance means. Choice is yours. Second option is becoming LIR and getting your own IP ranges, either IPv4 or IPv6 or both, and just implement them bravely, because all the cloud environments support that approach. And as a successful business, as you most certainly have, it will benefit you heavily in two ways. Either you are good purchase or you are a good purchaser. If you decide to acquire some company, it will be really simple to integrate them into your ecosystem. Regarding the same IP addresses topic, one thing to watch out is the elastic IP mechanism. The long story short, basically the only way to have a public IP address in AWS infrastructure is mapping it basically externally to instance which already has the internal addresses. Now the setup is not very transparent. It's difficult to see through the allocations, and it creates quite big security risk. You really have to know that this is one-to-one NAT, and it's just not any instance in your infrastructure, but it has basically public internet access to it, even though it seems to have the private address. So be aware of this. Regarding the security in cloud-native world, it's easy to say that the security has to start on step one and day one when you build the infrastructure, because any extra securing of things will be very, very complex. For example, you think that I have this interesting Kubernetes setup here running on VMs. I will just add, I will just throw in a stateful firewall next to it to make it secure. So it will be problematic. And likely the worst part is that you won't see these problems at first. How you usually approach by the enterprise mindset is that you monitor the traffic, create rule sets, etc. But the moment of truth actually arrives when the system is rebooted. Given the volatility of cloud-native setup, this Kubernetes most likely will not restore because you have blocked it from repos and also likely some other resources it requires to restart working. So as a failure mode, it's very nasty. And actually, in the cloud-native world in general, it's good to know that all the cloud-native systems usually require constant care, because as soon as you leave it just ticking, it will outdate, the versions will be old, likely you will not be able to pair it with apps anymore, and most likely the network problems will follow. So on the other hand, it's good that this property will not let you have much legacy. Coming to more recommendations, then stateful firewall is really cool thing to have in cloud native infra. I will not recommend any specific vendors, but it's very good standing point for a ground-based mindset to validate how your network traffic flows how your apps work, and also enforce policies on both security and BGP side. Why enforcement of policies when you already have the cloud platforms mechanisms? You never know about the essence and whereabouts of software bugs, so having the second line of defense is, in my opinion and experience, always a good idea. Regarding preparatory and developmental aspects, it was also mentioned earlier that the human resources part is very difficult to scale, so that the organization is also able to scale. And here I have put down some key aspects. What can engineering do in order to help their company grow as fast as it wants? Over provisioning was mentioned earlier. It's a good idea to do it, but you have to acknowledge to do it smart way. It piles of non-useful equipment or appliances do not do anyone good, but 30% of spare capacity is definitely useful, because it's like with failures, you don't know where and when this demand spike comes from. This helps you be ready. Perhaps the most important thing you can do to use the human resources efficiently is to build things properly. I think this is the key factor to success of rapid growth, because this approach frees you from turning around to the same solution. This is just a waste of time. The more you can avoid it, the better. Regarding outsourcing as the straw to increase human resources, it's kind of a double-edged sword. You have to do it really correctly. Otherwise, you are just risking to spend the same resource 3 times while trying. So it's not approach to take lightly. We have spoken here 45 minutes regarding the cloud-based version of things, but we have to remember that there is still the ground-based version of things also. And as much as we would like to connect the cloud directly to the office infrastructure, we can't. We still need to use physical equipment for this and physical media. And we just cannot forget about it, because at one moment of time we are going to need it. Also, we cannot neglect it if we already have implemented this, because it follows the rules of nature as the rest of things. It will break And if we are not prepared, then we are in the dark, regardless of how the cloud part is feeling. During the thinking phase for this presentation, I analyzed the experiences with cloud and ground, and actually the ground-based approach is really demanding due to one factor, the human part that is needed. The fact that you often need to cooperate with people, and in comparison to just coding, setting up instance in cloud, creating its configuration, it's devilishly difficult, because the human factor tends to do things often as they like instead of what is ordered. And the other factor usually involved in such projects is the project manager, who, as you all know, is driven by the deadline, and they are willing to make compromises in the name of the deadline. Which comes to the result that unless you really know your vendor and partners, you really cannot predict what you receive from them. And unless it's identical to your requirements, which are aligned to your code base, then you are at a high risk of getting extra technical debt into your balance. A bit of image which shows what denial of physical world can result in. Because when physical world needs to grow, then it uses what it can. If it does not have servers, then the next best thing to server is a laptop from your storage. And likely you will spend the laptop per application, and likely you will find a laptop infested server room soon, which will not look as nice as this clip art picture. Coming back to the ground-based conflicts, a lead of mine from the past said it very nicely, that what makes the difference of cloud versus crowd? Question is if we waste steel or not in terms of error. And the project management loophole I described earlier brings us just to that dilemma that if we receive a non-usable solution, what can we do? We can either scrap it or take it into our balance, and at the cost of extra human resources we need to spend there. The usual argument is a question of argument about merely seeming aspects like cable colors or equipment colors, but cable lengths or equipment colors. But I hope you understand what the different colored equipment mean. For example, if the design states that we're going to install green equipment there and receive blue, then we are pretty much in a tough position when the model is different and also the vendor is different of the expected solution. I think this we discussed also earlier. I would only bring out follow the sun aspect. When the company is big and growing, then it's very good to take advantage of the growth in terms of geography, especially the troubleshooting part, because when you have offices in different time zones, then it's very beneficial to also distribute support resources in the different time zones, so that you don't kill technicians in a single time zone with overtime. And the last point I would like to bring out is how to know that you're on the right way. Usually the solution will tell you. If it looks good and also applies to all your requirements. Unfortunately, I didn't have a cloud native solution to bring here, but this is the work of art. I would conclude my presentation pretty much. A few summary thoughts which we have gone through. A philosophical question point regarding the approach to cloud-based networking. Who do you think is in a safer position? Just material for a bit of thinking. And this concludes my presentation. Thank you. Any questions?
So, IPv6 is not really a thing in the cloud, right?
Okay, I repeat the question. IPv6 is not really a thing in the cloud. What makes you think that?
Because you talked quite a lot about subnet sizes and subnetting and overlapping networks. So pretty much all the infra is IPv4 only, right?
I would say the infrastructure is neutral regarding the version of internet protocol that you decide to use. According to the documentation from cloud vendors that I have personally studied, you can use pretty much any combination that you would like. You can use IPv6 internally, not it behind IPv4 in certain cases.
But usually it's not done because other applications don't really support it, or
Yes and no.
okay.
I think it's like a matter of taste and what are our habits. I don't see a problem with using IPv6. But the main thing I would advise is to find a unique addressing scheme. If the infrastructure is small, IPv4 is very nice. If it's bigger, then you might want to consider the effect of overlapping. Yes, it depends on the situation.
Cool.
So is
I would not comment that part. But I think you can see answers to this from public resources.
So was it cloud native from the beginning in Wise?
Again, I really cannot comment precisely on the aspects, but we are not. I would say we are not very different from other companies who hire smart people. That you work with what you have and with the technologies that are available, and then you learn step by step. In a broad sense, actually, the nature works in cyclic ways. So I would say it's like wrong to say that I definitely want to keep my resources on the ground or in the cloud. I believe that the right answer is somewhere in the middle, and as we are talking about business, then I would say the economic aspect is very important. For example, what are the pros and cons of each approach, and what is the current what does the current situation require? If my workloads are mature enough, if I know I use only Kubernetes, then in certain cases bare metal Kubernetes would make sense as cost optimization. If I need to scale up really heavily in some peak loads or develop a new service, then I would look into a more elastic solution. Yeah, basically, it depends on the situation. You have to find the right tool for the job, so to say.
No questions on YouTube.
Okay, I take it as feedback that either the presentation was really exhaustive or really boring and everybody's sleeping already.
If it works, it's boring. If it doesn't, it's you.
Yeah.